Hello, my name is Troy Rain. I'm the data science lead for Caltech IPAC IRSA. This video is about Euclid Q1 data on the cloud. It's part of the Euclid video series June 2026. IRSA serves Euclid Q1 data both from our on-premises file servers and from an AWS S3 cloud storage bucket. Here we'll talk about some of the advantages of accessing the on-cloud copy and how to learn what's there and how to access it. AWS S3 technology supports very scalable analysis. You can access one tiny thing if you want, and you can scale way up to accessing hundreds or even more files concurrently. This really supports massively parallel access. Access is totally free. You don't need AWS credentials, and you can access from anywhere. You can access from your local computer, an AWS or Google Cloud server, your department's HPC cluster, etc. You don't have to run your analysis on the cloud just because the data is there. Here's a link to the Euclid section of our Cloud Data Access page. If we go there, we see the Euclid bucket information, like the name and the region. Clicking this link for the browsable directories, we can actually browse the bucket from the browser right here. Here's the Q1 datasets. These are organized by tile ID, and we can click down all the way to individual files, and we can even download files right here from the browser. Actually, don't want to download that right now, so I'll stop that. This is a brief description of the data products that are in the bucket. This merged objects catalog is an enhanced data product created by IRSA. It's a combination of most of the Q1 catalog data formatted as a HATS catalog. We'll talk a lot more about it in the next video. IRSA provides a bunch of Python tutorial notebooks covering Euclid Q1 data. The four listed here are specifically related to the on-cloud data. This one teaches general access and gives examples for images and spectra. These three are about the merged objects HATS catalog, which we'll cover in the next video. Let's go to IRSA's landing page for all of our Python tutorials. In the table of contents here, let's expand the Euclid section. And let's look at this Cloud Data Access notebook. The learning goals tell us that we'll learn about the bucket contents and then load an image cutout and a spectrum. If we go to section 3, here we see how to browse the bucket with the S3FS Python library. We got the bucket name from the Cloud Data Access webpage that we just saw. And here we make an anonymous connection so that we don't need any AWS credentials. Then we can do various file system-like commands. This one is listing the bucket contents. It shows the same thing that we saw when we browsed the directories a little bit earlier. First, there's the top-level directories for the Q1 data release, and we can get all the way down to individual files where we can see the full path in the bucket. This user guide describes how to interpret the file names and the paths. In section 4, we'll get an image cutout around a set of target coordinates. This gets the RA coordinates using AstroPy. Then we'll do a quick search here to find all the images that cover those coordinates. This query SIA call calls an on-premises IRSA service, but it's just getting the path names. It's not getting the actual data. And down here, we see the paths to the images in the bucket that cover our target. Now we can load image cutouts around our target for all 4 Euclid bands. We use the AstroPy fits.open function. And this is very similar to what you do with an image that you have on your local computer, for example. But here we're using the S3 cloud path to get the data from the bucket. The image files are quite large, so we don't want to fetch the entire image. And so we use the AstroPy cutout 2D method, which reaches into the file and loads only the patch that we want. And then we use matplotlib to plot the image cutout data. And we see the Euclid Y, J, H, and Viz bands cut out around our target here. Finally, let's load the spectrum of our target object. The sections we skipped show how to dig into the Euclid catalog files and then call an IRSA service to get the object ID. But we could also get the object ID from the merged objects hats catalog, which we'll talk about in the next video. To get the spectrum, we use the object ID and query IRSA's TAP service to get the file path. This is similar to what we did for the images. And then we can again use AstroPy's fits.open with the path to the file in the bucket. These files contain spectra for many different objects, but we only want the one for our target. So that's what these lines are requesting here. And here's our spectrum data in tabular format, and we can visualize it using matplotlib. So that's an overview of how to access data from the cloud storage bucket and some specific examples for images and spectra. We'll cover catalogs in the next video. Thanks for watching.